Alright, day 34 of Protex. Today I'm going to be tackling work on having the extractor ingest our new binary artifact that we successfully produced yesterday. There might be a bit of work actually fixing the packager, the thing that generates the artifact, because it may or may not be broken. We haven't even tested it yet, so first what I'm going to go ahead and do is actually begin working on porting the extractor. And before the sunlight hits my monitor, I'm gonna switch to this blinding theme, just in anticipation for... And I'm gonna close my window as well. It's like... Alright, so I need to go ahead and open Protex. We're interested in the actual protex.zig file, and for the purposes of this, I also want common.zig so we can get a good look at the actual artifact. And again, hopefully it looks like this, but it may not in actual practice. So a bit of background on what we produced yesterday. So we introduced the concept of an operation queue header. Let me turn the music down just a tad. Not that much. So introduced the concept of an operation queue header, which is simply just a count of the number of operation queues that we... or number of operations for this operation queue. And then we also added, in place of categories, we have the number of operation queues. So a number of these things, basically, a number of these headers nested by the operations. So the idea being each path that you could trace to a end node in our configuration system, in our GUI, gets its own operation queue. And that's pretty similar to the concept of a category, which I had in earlier versions of this extractor, where you could configure multiple categories, and then each of those would be run one after the other, and spit out a different category of the extractor. But now we're just unifying basically everything into one extractor, but it gets this visual configuration thing that can generate multiple paths of output, if that makes any sense. So I did something weird. It like hid my... Everything went invisible for a sec. Don't know how to do that again. But I haven't actually touched the protex.zig file, so I have no idea if... well, I know for certain it's not working, but I haven't touched it, so we need to modify it now. And the way to start there is actually in the init code section. So basically, here we need to identify the changes, and we can start by actually peeking at the structs that need to change. For certain, cat box doesn't exist anymore. And in its place, we now have... I don't know why there's a space there. That's kind of weird. We no longer have cat boxes. We have operations. So this would become on a set of operation queues, I guess. So for starters, let's make that change. Do this. Op queues. I don't want to type operation a bunch. Op queues seems fine. I don't know if I'm gonna regret doing this. It might be okay. If I get annoyed, I'll fix it. But right now, this is an operation array of operations, or a slice of slices, basically. and that is how we're going to lay them out. And where is... If I jump back over... I would like to jump back over here. For Coder is really weird about how you can jump panels. I don't know if there's a hotkey other than the default Vim, like Control W, H, or L. There's change tab, change active panel that I could press a bunch, but I don't want to do that. I don't know how to switch panels. Can I click? Okay, I can click. I'm just gonna start doing that because it's more consistent. It's 100% consistent rather than pressing Control W and hoping that I switch panels. So, again, we have our context header, and we can have, I believe, multiple extraction context counts. So, and these are just contiguously laid out, right? So, that just gets a, yeah, so this is good. We will have one operation queue, one operation queue of queues. Call this a list because it's really not. It is a queue in the sense that one thing is happening after the other, but it's not a queue like functionally, right? There's no specific queue operations that are happening on this data structure. It's literally just a slice of slices. So contiguously laid out operations, basically. So, again, catbox is no longer existing. If we come up to our data structures that are now defined, we have, how many new op related things? Quite a few related op things. So we have all of these. Okay, so an operation header, which just defines the op type, which is passed as the first thing, which is passed as this guy here. Operation type followed by artifact or operation data, which is here, which is just a packed union. So the type will inform how we need to treat the data that we're reading. And it may be wise to simply just serialize, actually just serialize a piece of, I will show you what I mean. Over in Packagerland, we serialize, if we write all, yeah. So we treat new operation as bytes as a whole. We don't write any given particular property of it. We don't write a particular struct. We write the entire thing. So I'm wondering if instead of, I wanna keep treating this as a union, right? So I can represent both things in a single data structure. So I can hold both things in a container at the same time. I don't have to maintain two lists. Basically, instead of writing the entire thing and having the Zig standard write struct complain at me, I instead just write, in the case of PyModule, I write new op.PyModule. So that is just the case of writing a struct at this point. So we would write the specific struct instead of trying to write the union. And from my understanding, this will just be, this should be okay, because if we've set PyModule up, we should write PyModule and then whatever's bigger between PyModule and capture. But we'll write the PyModule data properly, i.e. just an index, and then we'll have garbage data for whatever was left in capture, because it's larger. So we're going to write garbage data. Which should be fine. So when we go to, and since it's packed, when we go to interpret the in protex.zig, when input goes and reads the operation, we should just be able to read the struct. Well, if we read all, if we have the parallel call to read all, I think it's read all, read bytes, read n bytes. Yeah, so we have a read all function, and if we treat yeah, so essentially we can create a stack value of our RDOP, and we should be able to call read all, and we shouldn't have an issue. If we do have an issue there, I can go back to the strategy of just writing the struct rather than the union, declaring the union, writing into the actual struct field of that union. So I could try that. This is just, I think this is cleaner. I don't know. I think it's more straightforward. Again, if stuff breaks, then I'll go the way I just described, the alternative method there. So we're doing some Python module data initialization. None of our Python module stuff changed. What did we change though? I think we changed we now just have a cat box has a conditions array. The conditions array used to represent the pattern IDs that needed to match, but we don't have that anymore. So let me go ahead and try writing. We might be able to just get away by not, if I just declare all this stuff here and don't prefix with RD specifically, then I can reuse this struct, which makes sense to me, and just get away from the RD prefix convention. But I think I have specific things like extractor def. Does this line up with where's the extractor definition header? And extractor name bytes. That doesn't match. Well, I guess that lines up with name. Yeah, so this is totally different than extractor def, because this also contains the data. This is like just a header too. But this data structure here is simply just the op type. So I could have packager also import from protex.zig as well for the data structure. Let's see here. Apparently control WL is working to switch between them. Right now it's just importing from common.zig. But yeah, I could also pull this from here. What else would I want to attach to? I for sure need operation header to live here in common.zig. I guess RDOP queue header can also live here. And then I can move these guys out, right? The next, this is just PyModule. What else was I recording with PyModule? For a cat box? Nothing. Just the index. And this also had pattern ID and offsets, which was stored in conditions, and we're no longer recording a name, which cool, just less bytes to worry about. I'm gonna do it. I'm gonna move these guys. Op type, op. And op capture, removing the RD prefix. Importing from instead importing from the actual classifier or extractor protex.zig file. I can make it over there maybe, Control WL. So just like this, and then just those lines, and then over in where's packager? Packager needs to now take so that'll take Protex as well, and instead of common dot arty, we're looking for this is that's fine. This is zig.op. Zig.op. I say zig.op, I meant protex.op. That was dumb. Oops. And I was searching for common should be protex.op type, and I also recorded op type, right? Yeah. Protex.op, and that looks good. Let's check if we can't. This should break because we aren't compiling Protex at the moment because that got commented out. Let's keep exploring this file and see what else needs to happen. I guess I am breaking the convention of the common file also not having the common things that are shared between stuff. I guess that's why it was existing in the first place. So in that context, why explicitly just put it in? The idea is we would just import one file. I think I've changed my mind. I'm gonna go find these Protex, replace these with common, and I will keep the convention of... I will stick to the convention Protex. I think that's just the only appearances. I can replace all these with and nuke that. So now what do we have? We have separated out artifact header structs, and we have, I don't know what to call these. These are structs that are shared by both the packager. We have packager structs, things that are shared by packager. I guess like everything in here is shared by the packager and extractor, but these are fully shared. I guess these are artifact. These are just like structs. I don't even think I'm going to prefix them with anything. Maybe they're Protex specific structs, like this is a Protex op type, this is a Protex op. I don't know. Whatever. Let me continue over in... I can't get over there with my keyboard. Gotta use my mouse. So this is now common.opq, but I can actually get away from that by asking for const. We have pi module. Perfect, so we can just remove having to use the common prefix. So we define operations. We now have definitions of definitions for operations. We now need to say just never removed that. Maybe I nuked something else that I wasn't supposed to. I think that's good. What did I change in that file? Add the preview for protex.zig. Just cat boxes, and I removed the white space between name and everything else. Somehow that's like way indented for some reason. Weird. Let's also fix this right now where we have over in build.zig. I commented out everything that wasn't the packager, but I want my builds to now actually, you know, build everything. Yeah. Looks good to me. I don't think anything looks obviously broken. Let's try it. Let's try running Alt M. There we go. Perfect. So we are seeing Protex issues, which is exactly what we expected. And apparently a purple screen. I'm very pleased that it went away. What line was that on? Line 227. Let's toggle line numbers. I need to set up my forcoder.config file. I also need to write a pacman make package file for forcoder. I might do that later today. And I might also fork this Vim compatibility layer or start contributing to it because it could use some work. Where's my FPS meter? Whoa. Where's toggle FPS meter? Okay. Toggle line numbers. Also toggle line highlighting because that's sick. Yeah. Look at that. Now I need to toggle relative line numbers. Oh my god, it's beautiful. This is everything you could want from a code editor. Maybe not everything, but you know. Sorry, a text editor. But alright, I'm getting sidetracked. 227. That's where I need to be. And that is where I will go. Yes, read category data, of course. Now we're reading operation data. That is the change. So we say, okay, we're going to alloc some cat boxes, which seems reasonable, according to the number of categories. We read this definition header. So definition header no longer has, where did we instantiate it? There. Definition header no longer has n categories. Definition header has n operation queues. And again, let me just open common.zig so we get a nice little reference about all of the fun things. This is the guy that I'm after, so I'll copy that one. And I would like to move over to the other panel. Sometimes work. Like, look how good it's working now. If it could continue working that good, I would be very happy. So according to an operation queues, we're going to allocate that much, that many holsters, you could say, block containers for operation queues, but we need to, now we need to actually, well, we don't need to do that bit yet. This is the actual wrapper, the number of containing slices that we have. So this is extra def instead of cat boxes, again, this is just op queues. So op queues, wonderful, very short, much good. And we're not allocating cat boxes, we're allocating slices of ops, basically. Where is op? This was line 227. I need to add a hotkey. I need to add functionality for like just pressing a number. Wait, is it working now? Why does 10 work? Move down 10. Oh, because it's command. Like there's no 20, there's no 30. I want 30. I want typing in 30 to take me to line 30. Like that's a feature that I use all the time. Definition header. What am I doing? I was thinking about op queues, and I was saying, what type are you? You are an op. Op is pulled from common.op. over here. And op is apply module or capture, so it's a packed union. So we're reading op queues. And for each cat index, this is now an op index. So we'll replace this. And what was this actually doing? This was reading each cat header. So we're back over in common land. We need to take a look at each operation queue header. So we need to find out how many operation queues are in here. So for each op queue header, so this op queue index, query replace select replace. Replace in range is what I want, I think. Query replace selection. Yes. That's what I want. Replace. No, don't do that. Query replace. Query replace, range, I think. Range, was it range something? Yeah, replace in range. We wanted to replace cat index with queue index. Nice. So for while our op queue index is less than def header dot not in categories but n op queues and not being consistent on the naming, this is now I need to spell operation queue. Yesterday I was feeling like spelling. I was like a mole, or I was like a whole word kind of guy. Today I'm a abbreviation type guy, and that will for sure come and bite me, but that's okay. Operation queues. So we increment the op queue index, we derive a header of some sort. This is now an op header, and this is an op queue header. I think the distinction between me using common as a prefix and me not wanting to use common as a prefix is the fact that I'm storing these structs like just outside of I'm storing these structs here rather than not storing those structs there. And I don't know, that seems like reason enough to me, but that's just like what my gut was telling me to do. I don't know if that's wrong or correct, but I think it's kind of interesting. Moving on back to operation data. Again, we need to take a look at queue header. So we get the queue header. The queue header contains simply the number of ops. So I believe we need to iterate over the number of ops. First, we need to, we're going to need to allocate, some stuff. We need to allocate, basically ops into our op queues. So allocate our ops, and then we need to look at each op and essentially read its data. So for operation index, op index size is equal to 0. Basically, pressing tab a bunch, hopefully that's not actually tabbing. These are just spaces, I don't know. I think it says use spaces. BYP space. Clean trailing white space. Start game loop? What? Okay. I probably, knowing this being a Vim compatibility later, I probably control it with H, J, K, and L. No? Do I drag it? I don't know how to move my big red cursor. Whatever. That's hilarious though. I would like to get my tabs working. I don't know what that does. Tab. Set. Ooh, marks are good. I'm not sure though. Okay. So for op index, while our op index is less than our basically our header, op header dot while it's less than nops, we're going to keep incrementing our op index. We're gonna do some stuff, presumably. So here's where we're looking at each op. So in terms of how we're going to do this, we need to declare an op. So here's our op. It's an op, and it's undefined. We're going to say Mr. RDF. We want to read a struct just like this. Try reader dot read struct into our op. This is of course after we've understood what type it is, which we're not recording the type of the operation. Can I... Is there a way for me to... Okay, so this might be some concern for separation. Is there a way to have a... Basically what I want to do is I want to say, according to your type header, so we need to, prior to looking at each op, we need to look at the operation header itself. So this guy here, we need to understand which type it is, and then according to the type, we actually instantiate a tagged tagged union. So I need to read up on those actually, because I've never actually worked with them, and you can't have a tagged union being serialized. I just saw union, tag union. That's a little too much zoomage. That's too much zoomage. That's perfect. Unions, tag union. So this is similar to our op type. We have an op type. We have some sort of union. I see, you just give it a complex tag type, and then when you go and read it, what exactly is happening? Oh, okay. We can say, what exactly? This is saying cast C. We say complex. Okay, so we're basically, you could switch on expecting this to be cast, this cast to be true. So we're casting C to a complex type tag. And we're expecting it's okay. And then, yes, they're switching on... Oh, wait. They're just switching on C at that point. And you can say, okay, what's your type? Are you this or are you this? This is exactly what I want. This way I don't have to, like, store the type in the data structure. And then you could, yeah, get tag type via standard.meta.tag. And you can course it to an enum too. Interesting. But yeah, this is what I want here. I want this specifically. So these get to be common again. So how do I want to have a... I want to have a distinction. Op type is fine. That can stay. Op needs to be a tag union. So tagged op. Tagged op. Basically, I want to have... This is the common op. This is the common op that we're using. And I want to have a tagged op as well. So with this guy, this is like a serializable op, is what this is. So this is a packed op, is what we're dealing with. So the packed op, and I believe I am good with how these are being deployed. Well, I've got structs, which is fine. I assume that's okay. We have common, we have serializable ops. So we have a packed op, which is serializable. And we have a regular op. So we have a tagged op, I guess. And basically what I want to have as a tagged op, let's move this stuff down here below this. Just like that, const matches a struct. So our, again, we have a packed op is common.packed op. And I might leave that as and I don't actually have to serialize the union if I just make, so if I just do this, actually, if I do this, I don't make this packed, I don't serialize op, I make this a union, tag union, I give it a op type. Here are all of its types. Clear that before I use it. Don't think it matters, but and this is not and so this is an RDOP pi module. Oh, I need to fix that. That is just an op pi module and an op capture. Just like that. But yeah, this is an op type, and the op type, we are now serializing We are serializing these. We're no longer serializing this entire thing. So I feel like this is the better design, and we can just go back to using op, common.op. And so packager needs to change now. And instead of writing instead of writing all, wait, I can still write all. I can still write, but write struct still writes all. I just call write struct now. So with the added benefit of enforcing a known layout, writer, we're writing a struct. And yes, I need to do that in here. I'm writing the specific struct. And it doesn't, it just takes the actual struct itself. What are you closing? Nothing, you just need to be indented. So we have new op, and it is just a pi module. A pi module that looks like this. So it looks like this. What was that closing? I think it was just closing this. Yeah, so just like that. And then again, try writing the new operation. And we should be writing the type. Common.op type. And again, this will just inform what we're actually reading. And as far as actually declaring the type that I want to use, I guess it's just instantiated via here's what I assign and done. Eligible to use switch expressions. Okay. Again, this is great. Write struct new op. This then becomes copy pasted into capture. And this is just a common dots capture op capture. Right struct new op. That looks good. Let me try building. It looks like we don't have issues with packager, maybe. At least the issues that it's finding are, you know, mostly located in the issues that it's reporting are just protex.zig for now, which is fine. Where? Why am I not? What did I change in common.zig? Maybe the tag union? Let me open protex.zig. So, this is no longer shared. The op type is shared though. And yeah, this guy gets to exist outside of the common.zig file. I could also pull all these out into just a Protex structs file as well, which might be wise, maybe. How many of them actually are there? Not a lot. That might not be worth it. So when reading operations, we ask for operation queues. We then go read the queue header. We initialize the appropriate operation depending on the data that we've read. So we need to actually switch on the type. So we need to get an op type. And in this case, we are reading an int, actually. Read int. Do we have that already somewhere? No. I'm gonna clone this. And I want to go to, instead of tag union, I'm looking at standards. Again, whatever nittiness that I asked it. It's whatever byte order. So it is simply just readint, the type that you want to read. So we're r.readint. The type is at, well, the type is a op type. And it should be just a usize, but am I doing that explicitly in packager? I think I just understand that that's a usize. Where I serialize op type. We're just writing a usize. Yeah. So, okay. Basically what I need to do is we're reading an int. Can I get the tag? Is there a way for me to get essentially a enums? Go back to one. Clone this again. Is there a way for me to get the? I think it's a tagged enum. I'm gonna use type of here. Externenum. Gets me a standard.built-in type. I assume this is referring to this layout. So I can ask for its type. I can say at typeinfo.type on the, so I can say at typeinfo.enum.type. So and then back to readint, wherever that was. Right, I need to pass an ediness. Is type info, was that capitalized? See, there should be like a C also type info. Wait, was this what I was looking for? It was lowercase. And presumably readint just returns the value as well. I don't think I passed the value to it. Yeah, error T. So trying to read type here gets me the operation number, and of course we're going to want to cast this to at go the at int enum route. So op type, don't know if I've got the right amount of parens here. That's readint, that's int enum, good. Right? Yeah. So now we have an op type, and then depending on the op type, we can read the appropriate struct. So again, this is a this is an operation, we're not defining it. Can I initialize it though with a specific type? But I think this was set, this said a comp time value, which I don't know the type at compile time. That the field name is comp time known rather than the value. I think I do know the, I should know the value that I'm initializing. union type. So we pass it the union active field names. And then a net expression. What? So, right, depending on the op type, we're going to read the appropriate thing. Switch on op type. Depending on the op type. In the case of a Pi module, we're reading a Pi module, and we're writing to the Pi module field. Like that. In the case of a capture, reading capture, I assume this is comp time known, right? Read struct is comp time. That would be kind of sweet if it wasn't. It is comp time, unfortunately. Right, read the appropriate thing. These are all the op types that could possibly be. We initialize an op. And we write the operation to our the op queue. So whatever op queue index, that's what we're writing to. So it'll look something like this. We say exter def.op queues at the current op queue index. At the current op index is getting assigned this new operation. Very simple. Here's where I need to declare operations. So in terms of basically exter def at op queues at the current op queue index is getting a set of operations according to we're going to alloc that many ops. Oops. Op queue header dot and ops, just like we're doing right here. And so get the header, allocate the data, allocate the slice, get our index, look at each operation for this particular op queue. One sec, let me refill my mug here. This is going to be cold, but as they say, cold coffee is better than no coffee, so I don't know if people say that, but maybe they do say that. At least I say that. And it is exactly 10 in the morning. And the light I don't think is hitting my monitor. I can test, try to change this abomination of a color scheme. Yeah, that is absolutely seeable. Visualable, readable. There's still a bit of light hitting my monitor, but it's okay. That is some lukewarm brew. Okay, so we just finished reading the op type, and I was reviewing code for actually how that is working. So again, we allocated the slice, and then we're writing into the slice of slices at the appropriate op index. We write the op, and everyone's happy. We were also reading name. Name conditions, and that gets to go away. And instead of doing that there, we're doing this, just like this. And then we append the new extractor def, which we made. And then I have a scratch buffer, which I'm initializing. Cool. And that should be all the init code done, actually, which is sick. At least for today's purposes. Just conform to my new stupid conventions here, which I change weekly, so that's fun. Give it some nice white space. Just like this. Alright, so now we need to start modifying extract code. Let's see what the compiler has to say. It doesn't like the colon. Am I backwards on my syntax? I think I'm just passing bad syntax. I believe this should be a while loop. I have another for loop where I was doing something silly. That makes sense. Don't do that. is down in extract, which makes sense if it is. This is our dinit code, so this is going through and freeing everything. Wouldn't it be nice if this was all just an arena? That would be pretty nice. I think I'll do that in the future. Okay, so we have our extra defs. It frees the definition name, sure. This needs to look at op queues. There no longer exists a name, there no longer exists a condition. What is there to free? I don't think there's actually anything to free. Because it's all stack, it's all known. That we're not holding bytes inside of these data structures anymore, which is great. But that will probably change. So I need to free the actual... I need to free each slice. So for each op queue, I need to self.le.free the op queue itself. So this is freeing each slice within the slice. This is freeing the slice container of slices. This is freeing database bytes, extra defs. This is deinitializing SumPy. SumPy notice me. 335 now. Yes. Alright, so we get into the wonderful world of Protex's extract function call. That's kind of obvious. Store hyperscan matches somewhere. Allocates fixed buffers for stream and SumPy outputs. Okay. Like the initialize is obvious. I'm gonna just this is an output stream for the JSON writer. I think that can just go away. I need to fix this nonsense. So we declare our writer, we start writing objects, scan this extractor's hyperscan database. So I clear the retaining capacity, so this is like resetting the match list, which we're using to store match indices or matches from hyperscan. Decide how to handle multiple matches within the same category. I don't know what that means. Multiple matches within the same category. I think I know exactly what that means. Like just one pattern. I guess I can leave this to do. Like one pattern matching multiple times. I think the current logic just looks... I think we can actually just operate on multiple matches, which is what we're doing currently. Which I think is the desired behavior as well. I'm not sure. And that's probably why that to-do's there. I'm gonna remove this cat box because it's pointless now. don't like this function. Do this, then this, then this, then this. That's what I want to do. Alright, so for each operation Q is what we want to be looking at. So for each operation Q, what are we doing with that operation Q? We're looking at all of our matches from Hyperscan. We're doing a bunch of stuff. Okay, we're doing some stuff, and I can remove this nonsense. Did I? Current token, blah blah blah. What was this about? If target pattern ID, try and format. Oh god. The target pattern ID is actually just opq. This is opq. I'm saying continue. If we find this match in the match list, then continue. This was not equal to. This is just saying we found our match, so continue. And then so this is just matches, okay. This is senpai run, cool. Oh. If we don't find this match in the match list, then continue. If this isn't the current match, then continue. So this comment's just wrong. Like, cost me at least like a minute and a half, maybe 2 minutes. Less documentation is the best documentation. So if we don't care about this match ID, it's not reflected in our operation. Well, how do we want to actually do this? I need to rethink this entire loop actually. We're looking at each match. So this is coming back. So Hyperscan is coming back with the match list, right? I am iterating through operations linearly. Like for each operation Q, we're gonna do this set of steps. So what is the first step that I'm doing? In the case of a I need to enforce the case that you can't. I think the GUI will actually, and the packager or the extractor later will enforce that the first step that you need to take is either a capture. It has to be a capture, unless there's like other operation types that I introduce, which is extremely likely. If it's not a capture, then we're gonna just say, hey, this is a bad configuration. This is a bad artifact that you passed me. Hey, go, configure again and try to run. But so if we're encountering a capture type, so if the current operation that we're looking at is a capture, did we match the pattern ID? And we need to do that we need to look at each match item for each, we actually need to look at every match for each operation that is a capture, basically. So when iterating over the op queue, instead of iterating over match list items, we now need to iterate over the op queue. We need to iterate over the operations of this op queue. So for essentially op queue, Whoa. Well, isn't that fun? I love when my editor just, you know, freaks out. I wonder if it's because I'm on Linux. That's probably exactly, or it's because I'm using a compatibility layer that's broken. Delightful. Not this theme, I still can't see it. This is nice and large. I'm a fan. As I was saying, we need to look at OpQ. It's been so long since I've touched this that I actually, you can just iterate via this. Yeah, so you can just pass the self dot. Oh, sorry, we're already doing that. Where is we pull extractor def off here? OpQ. For each operation in this OpQ. Don't use tabs because I'm scared it'll screw up my formatting. Because 4coder's a strange lad. Okay, now we're dealing with ops. So, yeah, I need to switch on the op type. I will do that now. And now, the payoff for me keeping this tab open. I said the payoff for keeping this tab open. Switch on the union type, which this is, and we can say type.ok or whatever. So switch on op, wonderful. Syntax is delightful. Just do this. I don't like this though. I need to set up a zig whatever file. It's so annoying. I'm doing that later today for sure. I gotta do it later or else I'm gonna lose my mind. Or else I can't continue using this editor. I love this editor though, it's so nice and fluid and everything just flows. So op, so this is op type. So in this case, do this and don't use tabs because I'm scared again, formatting. Oh my god, what's going on? What's going on? There we go, I only need to write that once, and then we'll have the other. So this is op type dot pi module, handled that case, and then in the case of an op type dot capture, we're looking at all the matches, iterating over each one of them, which is may or may not be okay. We'll see. We'll have to benchmark everything. So in the case of a pi module, we are In the case of a Pi module, we expect that there was some previous bit of input to feed in. Let's pretend it is always a capture that precedes a Pi module. Like, that's a naive and breakable assumption, but for now, for testing purposes and just getting this working, let's assume that if you're in the Pi module case, right? You're in the Pi module case. You are expecting some sort of indices to be available to you, i.e. from the previous operation in this switch case. If you are a capture, we need to look at each match list items. We need to look at all of these matches, and we need to record the match indices to then pass to Pi module or the next capture. Again, we're just performing some sort of operation depending on what's depending on the order of this operation within this operation queue. Again, let's look at an example of, okay, the first thing that I have is a capture. Okay, a capture simply has, I believe, just an ID. Is what we're going with. If I go to, where is com.sig capture again? Okay, so it has a pattern ID and an offset. It's a good thing that I remembered offset. So again, looking at this, we need to say, here's our capture. So for all these matches, I can remove this. If you aren't important to us right now, then I guess we're moving on to the next match. And target pattern ID just ends up being op dot op.capture.pattern ID. My brain was not working there for a sec. And this is a, what did I make match.id? I think that's actually just a C uint for match ID. Yeah, unfortunately. So I'll need to either cast, well, it's actually exactly what I need to do. I need to cast this to a C uint. So let's make these comparable. So if those aren't equal, then continue searching for, looking at the match list items. So that's that taken care of. This is this taken care of. I don't need to do any funny business with that. We are semplied running in the case of a Pi module. hopefully. Why is this a var? Or why that's a var? Why is mbytes copied of var? Froze. Like crash? I think this might be the first crash that I've had. Let's give it a sec. Oh, it is not responding. I'm going to try to kill the process. It's not even letting me kill it. Where is for editor? F9. Sig kill. Ew, I don't like this color scheme. Is it time for flurry? Go back to this color scheme. Alright, did we save most of my stuff? I lost match list items. But the intcast stuff is still there, so that's cool. If it happens again, I'm moving back to Vim for the rest of this stream. So case capture, we're looking at our match list items. We're asking if alt capture pattern ID doesn't match, then continue. Otherwise, we're doing stuff. We need to record this match. So I guess we could record a last match index, like the match that we care about. Right, because that makes sense. Like we keep track of some sort of match. So I guess we let our match type match. So just match. I think they're just matches, right? Yeah, it's a type match. So we let our match be undefined. So this is like last match, like match. Current match, I guess. Current match? Current match. I also want to record an offset. So in the future I should probably bundle these things, but that's okay. It's good for now. and I'm being a TypeScript programmer. There we go. Too much TypeScript, if you ask me. I'm toying with the idea, and it's really scary, but I might rewrite the GUI in just vanilla Zig. I think for the purposes of like a prototype, which is the current state of the GUI, building it in Electron makes a lot of sense since it's so easy to build functional things out. Like you can just make stuff. The problem is it's Electron and it's a giant web application when it doesn't need to be that big, you know? But in time, maybe in a year, maybe in 2 years, who knows? Maybe next month. The future of Protex. Okay, so we're looking at our operation. This is for each operation. This needs to be hoisted to the scope above the scope because this will not work. Stop nuking the line there. There we go. Do what I want, not what I tell you to do. Current match, current offset for each op. In the op queue, we're switching on the op, we're getting a capture. If this is indeed the capture, if it's not the capture, then continue. Otherwise, is this necessary right now? I don't think this is necessary. If this is the capture, how about you just break? And how about you also set last or current match equal to whatever match we're dealing with. And how about you also set offset equal to op.capture.offset. Wonderful. So we found our thing that we're wanting. So this gets back to how do we handle multiple matches within the same category. Like what happens if we have the same ID matching multiple times? Right now we're just ignoring that. You get the first instance of that thing, we're done, we're breaking, and we're going to go handle it somehow. So now we're in Pi module land after this. So now that we have our current match and our current offset, we can, for starters, remove all this nonsense, which never should have existed in the first place. And we can do this as well. Yoink. Press spacebar a bunch of times. Again, why is this a var? I have no idea. Do I reuse it like an idiot? No, I don't reuse it. I just this should be this. There we go. Wonderful. Makes me happy. endless categories, JSON blurb, da 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 da. Endless operation queues. Config client. It is a web client, but be explicit about what the thing actually is. And this is exactly for config client's benefit. And I don't know when to do these things, probably inside of Py module, because I guess I'm also making the assumption to get this off the ground that you end with a Py module. We only want to do this. We do this thing if this is the last, we do these things if this is the last operation in the queue, right? This is happening. Begin object fields. This can just be, what other object fields are we writing? This is the category name. Begin object fields. The object field is the script output. So the array elements, the array is a list of objects. We're beginning an object, we're beginning an object field. Output capture? I'm just going to describe this as output for now. Just out. And again, we're ending a JSON blurb and we're actually running this. When are we beginning in, this is the array elements. We're adding a new array elements to, whenever we do an output, again, this is just assuming that, so this is changeable, I guess. We're already beginning an object. We're writing the object field out. We're doing those two steps for sure in here. Use spaces, please. I think I'm gonna go, after I finish the stream, I am going to go to the gym or take a nice long walk, and then I'm coming back to 4Coder and I'm fixing this tab issue. I don't care how long it takes. And then write that as an output field. And we are beginning an object for, it's pretty easy when we begin an object. We begin an object for every operation queue. So we're beginning our elements and we're beginning an object. And we are setting outputs. We do this if this is the last. So we also need to record, the last senpai module output. So like after a senpai run, how many bytes are being copied? Do I just record the bytes? What happens here? So if we think about this for a sec, we have a main Py module index. This is wrong. This needs to be index. This is op.index. Op.pymodule.index. just like that. Almost like I planned it. We have our Senpai run buff, sure. We have our match start of and match end of. This is now, instead of match.start of, this is current match. And we have current match. And really what this should be is these are the last known indices of, and my buffer froze again. Oh god. Alright. It's Vim time. And you wonder why people don't use 4Coder on Linux with a Vim compatibility layer. You are my new code editor, Mr. Terminal. Wonderful. Hey, and I've got syntax highlighting now. Oh, where else did that happen? Yep, there. That is hilarious. Oh my god. Okay. God, everything is all out of whack. I'm having so much fun redoing work that I've already done. Something that 4Coder certainly does have over Vim is like you can Alt-M hotkey run your build script, and I'm sure that's configurable in Vim, so maybe it doesn't have it beat, but that's like a nice out-of-the-box feature that it has for sure. And of course it's like all smooth and fun. It's fun until it isn't. Just making sure these are all kosher. If people use that word anymore. Look at that. See, it's highlighting. Where's my mouse? Look at that. That's wonderful. Can see squigglies. You might actually be in the right spot. Is this in the right spot? I think it's in the right spot. Nice. That was hilarious. Or is anything broken up here? Oh yeah. Surely common.zig is broken. Yep. Also, this is probably... Why am I even asking at this point? How did this happen? I used tabs instead of spaces. And then for coders just treating them as spaces. Like, it's like my tab width is like set to 1. I don't even know what's happening. Whatever. That wasn't horrible. I was expecting that to be a lot worse. Looks good to me, for the most part. Well, all these color schemes suck. I want the red color scheme that I had. This one's kind of cool. What is this? This is default. This is default. This one's kind of cool. It's hard to see what I'm highlighting though. No highlight line cursor. Set no cursor line. Yep. Now everything's mostly seeable. There's still light's a little rough with these black color schemes, but so switch on the current operation. Actually, this doesn't look too horribly broken. That's busted over there. Look at it. Look at Vim being all smart. Actually, what does this belong to? Hello? Wait, is there anything else like that? Oh god, there is. Who else is in the stratosphere? Just those two, apparently. And the funny thing was, there was another one. Alright. Get back to some sane formatting. And I was trying to work out how I want to forward indices to a Pi module, the Pi module case. So the idea was if you're given a match, record, and if you're dealing with an op type capture, record that and set the current match equal to the match that you just encountered. So we're going to copy that over. Once we encounter PyModule, we want to take whatever we previously had. So really we don't want a match, we want previous start of and end of indices. So that could be like a match, whatever. And after actually running a PyModule, we could actually set previous start of, previous end of, that sort of thing. So current match, we could actually set current match again after the PyModule runs. And we don't need to necessarily run out yet, but we do need to record this guy right here, senpai run buff. Otherwise, if we're not writing it, we need to forward this information somehow. Actually, I don't need to forward senpai run buff because it's 0 to n bytes copied, and where, so that transformed the data somehow. This is output. Now if this is outputting, basically all we know is how many bytes it copied. So given those bytes, how did it transform the text? Really, it can do whatever it wants. Like the text structure has changed, like fundamentally, because it's a Python script. You can do whatever as long as you're outputting a string. So my thought was I was like recording how many bytes were copied in the Python script. I can like use the thing that it outputted as basically just another capture, right? And then continue kind of recording the matches into the current match, and then, you know, capture PyModule, whatever. But that's not going to work. When you transform stuff, I think you actually need to do another hyperscan scan. Unfortunately. So on PyModule, on a PyModule call, you need to run a hyperscan on the thing that you spat out. And where do we go from there? After you get a scan result back, we set, so we run senpai, right? We run senpai, call this here. We get our senpai run buff here. We pass this to hyperscan. Hyperscan gives us a set of match indices. We do this exact same logic here. We do this again. This time, match list is actually just a, this is our sub match list. This is our PyModule match list. Really, this is our Python out match list. So this is like text match lists. These are text matches, and then we have Python out, whatever, PyModule output matches, fundamentally. So I don't like doing this. There's got to be another way to transform the text. But I think as a prototype, this is going to be fine, and then I can work out how I want to optimize it later. Because for each Python module that you define, you're doing a hyperscan call, and hyperscan calls are expensive. I would really like to just do a few hyperscan calls and call it a day. Good news for us is we can reuse the database, which we have lying around. So, in the case where it would be nice to, if I could reuse matchlist actually. This is an array list. Here's a thought. Kind of a cool thought. And cool thoughts are dangerous. But what if we just kept... Basically how match list works is we pass it as context to Protex extract. Or sorry, Protex callback, wherever that is. Our hyperscan match handler. We pass it as context. So it's this guy here. We call match list. And... exactly what am I doing here? I am calling append. There we go. We interpret context as a match list. There we go. That's what I was trying to say. We append it just to the end of the list. We append it to the end of the list. Instead of, well, we just pass match list again to, we are modifying match list, which, so basically this guy here, we're modifying match list. Well, we're modifying match list here, and we're iterating over everybody here. So if I extend match list, I just need to record the number of matches that were already... If I have a starting, basically, position in match list, I'm just trying to work out ways to get around instantiating a new array list to have to deal with. I would like to not do that. It would be kind of cool to, yeah. So what I'm thinking is something along the lines of, okay, let's record match list length. Match list length -1 is our actual, well, match list length. This is going to be our starting. This is going to be our starting index. So this is our start index, so as the starting index. That's going to be the starting index, so that'll be the very first item that gets appended when running a scan on the output of the Python module call, whatever the script outputs. So we have our starting index, and then we need to look at each value once we finally match our current match. So our match, once we match that, I also need to do something with offsets. Offset is just getting patched to PyModule, or it's being returned. So I'll work that out in a sec. But basically, I'll have this extractor actually deal with. I'm getting sidetracked. Too many things. Record the match list length as the starting index. We append items as would normally do, so we just call hyperscan scan again. And we then go through and for however many items we added, from the end of the list, just remove that many items. So just pop all of them off as we're reading them. So we just keep popping. Like to say there was 4 matches, we pop 4 times, and you're left with the same list that you started with prior to the secondary hyperscan call, and you haven't touched the initial list state. So I kind of like that idea. So let's get a starting index. And the number of items that we need to look at is starting index minus length, right? Because if I have a starting index of 4 and list length is 4, then taking starting index minus list length is 0 items were added. If starting index is 4 and new list length is 1, then I'm looking at 1 item. So starting index again is just match list.items.length. So that's our starting index, and then we're gonna have a n items, basically n new matches, n PyModule matches. Here we're passing run buff to hyperscan. We're recording our match list length again as the starting index. So we're doing that already. NPy modules is the starting index or the new length. New length. Minus starting index. And we're looking at from starting index to the rest of the array. Is this syntax available to me? I have no idea. I guess I'll find out. I don't think it is. I think I have to specify it. Whatever. For this, we get our match, just like we did previously. And we're recording whatever we matched. And we no longer break because we need to actually pop the number of items off. Well, we could break and just pop the number of items off. Yeah, we can do exactly that actually. So I need to look at standard array list. At the top of the file, please. So for matchlist.items, while so we need to have basically our match list index. So our current match list index is going to be equal to our starting index, and while our match list index is less than our number of PyModule matches, we're going to pop I don't need to specify items, do I? Yeah. And is it throwable? Does that throw? It does not throw. Remove and return the last element from the list. Asserts that the list has at least one item and validates pointers to fields of the removed element. So again, going back to our example, if we had 4 things originally, we find one new thing, our number of our starting index is 4. This is our starting index, and number of PyModule matches is the new length. Let's say the new length is 5, meaning our number of matches is 1. Our match index is the starting index of 4. So while 4 is less than 5, we're going to do this n amount of times, in this case 1. So that should be all great. Nice. I was gonna say kosher, but kind of cringe, so I didn't. We're popping matches, and once we find our thing, we're going to set that equal to the first thing that we find. We might also add a stipulation that if we've already found a match this time around, then don't add a new one. So I'm gonna do this. This is hacky, but we need some way of like popping matches still. So found basically assigned a assigned current match. Assigned current is what we can say. Again, this is a hack, so I'll need to remove this later. So if this and we haven't already assigned a current match, then do that. This is a hack because I want to so this is our hyperscan call here. And this logic only takes place. We can do this in a few ways. If we want to just have a single place to write the out field, i.e. when we are on our last operation, which is always what we're spitting out, we have a pointer essentially. We have a current slice. We're looking at a slice. We're looking at a current U8 slice. In that case, the last known slice is either last known slice is either a pointer to text, or it's a pointer to pointer in length, of course, to the senpai run buff. So we could do it like this as well. We have last latest offset, latest match, previous known buff, I want to say like previous text, previous extract text. It's just an array, a U8 array, and it's undefined. U8 slice, excuse me, I need to get that terminology correct all the time. Because it's not an array, it's a slice. This is like the previous step. I don't entirely like previous here because it implies that it was just the previous match, but it's the previous step. I don't know. And then where's my hack? Assigned previous. It's already spelled with 2 L's or just 1. It's just 1 L. Hyperscan call needs to happen. I can also implement this now as well. So our previous, extract targets. Last match, I kind of like last rather than previous. Our last extraction target was exactly this. This is basically cap, handle offset. I need to do that. So like this will end up being match.end of plus whatever offset we give it. And we just need to enforce that that is in range of basically text.length or whatever. And what are we actually passing here? This is going to become the last extract target, is what this is. So, because in theory you can, chain, pi module calls operations, which is what we will allow. I was just about to handle what happens when operations are the last thing. So which switch on op. For each op, we have an op index now as well. If this is the last op index, is that my op switch? Now, basically we do this. Do we need to do that? I am emitting a string of the last known. Is this in the same scope? This is. I am emitting last extract target from last match. Plus an offset. So this doesn't become some pi run buff anymore. This is last extraction target. We're emitting last extraction target with from 0 to basically last match dot start of to last match dot end of plus the offset of the match. And so again, let's do offsets. This will definitely be a function that verifies something. Maybe it gets you a slice of. So we're emitting the last extract target, last match end of, and again like plus last offset dots plus last offset. Spit out match indices for the client's benefit. We're emitting and then finally end the objects. Why are these indented? Why are you not indented? Are you just an extra? Where's your buddy? I don't think that has a buddy. That is the extractor depth, right? That is column 5. That is column 5. And then everybody in here can come to the left. So after we're done, we say object field out, start of, end of, and the object. That is beautiful. And I no longer have to do this. So now I need to get the hyperscan call in here. I don't need to clear the retaining capacity. And it's actually a pretty trivial thing to just call it, huh? This nice and important. So we're handling offset somehow. I guess I can initialize the last extraction target. The last extraction target, because we needed to start somewhere, is equal to text. Right? So this then becomes, instead of text, let's find all our instances of text. When does last extract target switch back? I don't think it actually does. We're actually done with text after hitting a pi module, because it's useless, right? We only want to then we only want to then come back to it after we restart the whole we go to the next queue. So having it be initialized to text here I think is okay. Again, so this is just last extraction target. Was I passing? Yeah, I was just passing the entire thing. Last extract target. This is going to be last match. Just like that. We're passing senpai run buff. We're passing up pi module index. That's what's being ran. I have no idea if this is being configured properly or not. So record starting index, call hyperscan on the current database. We're gonna call with last extraction target dot pointer. We're passing last extraction target length scratch match handler. We're passing it the match list as context again. We're checking this is over. Just like that. We ask it if it's already been assigned, or we set that it hasn't already been assigned. We get the match, we compute last match, last offset, last extract target. Our actual last extract target then gets updated to we'll actually show you. Last extract target becomes this, actually. Does it become this? No, we want to scan. We want to pass it. Well, we want to pass it to... Actually, that doesn't belong in there, does it? It should belong right here after we get our senpai buff, right? Right? Because... we're gonna update last extract target. Is this just extract target? I think current match, current offset, current extract target. I might go back to current. I don't like current though. So current extract target gets updated to whatever senpai run buff was outputting. Just like that. So senpai run buff. What is it scanning? Current extraction target. Perfect. So this is going to be text initially, which makes sense. Whatever was currently being assigned. We set it to the current module's index, which we know is indeed a pi module because of this wonderful switch case. We record the starting index, we scan on the current extraction target's pointer. Length self.scratch, we hand it match list, we ask if things have already been assigned, we fix our match list. And then, actually I think you just clear the routine. I think that's totally unnecessary, right? Because if you are a match after a Python module, you don't care about whatever matches were previously. But you do care if this is only happening once up here. We need to make sure these matches. That's why I did this, because I was forgetting why I did this way, because we need to maintain these matches. Don't throw these away, because we'll need to use them for the next operation queue. And we're only throwing away matches that are a result of the Python module scan. Otherwise, just use the matches from text, basically. Anyways, we assign current match, current offset, already assigned, and then this reflects what we just scanned. Current extract target. So this is text at this point. We update it to SempI output. We scan SempI output. We get matches and offsets from. We get offset from the current match, but I could always just cap offset to. I actually don't need to record offset. The reason is I can represent that in match, and it makes everything cleaner. Is there a built-in min function? So I could use that. There is. So basically what I want current match dot end of is going to be equal to op.capture dot offset. We're equal to the min. Well, we want the max, we want the largest value that is, if end of plus cap plus offset exceeds text length, we want to reduce offset to be equal to whatever the difference between those two was, plus end of. So for starters, what do I want end of to be? So we have an extended end of, right? So we have extended end of. Otherwise, it's just equal to text length. So it's either capture off.capture.offset. So it's either this plus this, or it's basically the length of length of current extract target. So if this plus this exceeds current extract target, then sets equal to this. Otherwise, we're setting current match dot end of equal to just add the offset to it. And we no longer need to record the offset. And how many places am I doing this? Actually, I might just need to do it here and here. So we'll also take note of the offset. Isn't it the case that I just want the minimum value of the two? Right? Don't I just want, this should actually just be, this should just be min of op dot capture dot offset. Should be end of. This is current match dot end of. And text length, right? I needed to kind of write that out first and then condense it into this. No, it makes sense. I no longer need to do this because end of is now in line with current match now also captures the offset. So that is just built into the, which is awesome. I needed to do this one more time though, I think. Right? No, I don't, because current match end of is now already recorded. If we don't have a current match yet set, pass the entire text. So let's see. Right, because if our if we're dealing with the pi module and this happens to be the first operation, then what are the characteristics of these variables here? Our current extraction target will be equal to text. Our current match will be undefined. So we actually know this. If this op index is equal to, if this is the first thing, we know for a fact that we don't have any captures. So if op index is 0, pass the entire text if op index, if this is the first operation. So if this is the first operation, if op index is 0, then we just record, we're going to assign current match to be equal to our current extraction target. And how do I construct a match? I can construct a match via looking at the append code up here. Current match is going to look like this. Start of is going to be equal to current extract. Start of is 0 actually. We get to ignore offset because it doesn't matter. Offset also, this is the first thing, so offset's going to be undefined. Anyways, current match is undefined as well, until now. Why am I still recording that? That doesn't need to be a thing anymore. match end of becomes and the ID is the ID is actually what exactly? Actually, I don't need an ID. ID is like a banana number. I think that's reflective because of the fact that I have a magic number 123 here. Basically, I want to initialize a start of and an end of. Do I just have that as a thing? Well, I want to stick with matches, so because I actually asked for match.id, right? Yeah, right there. And right there. And this code is the same, so I might pull this out at some point. Except for this guy here. Again, I'm passing the entire text. If this is the first operation, I'm giving it a garbage ID. So write the garbage ID, start of and end of. We're going to be passing current match, start of, end of, current extraction target on the index. This looks good, but I'm sure like 52 things are broken. So let me make sure that this is working still. Looks like it's working still. And I'm gonna run zig build and see what breaks. Op pi module. Line 16. Oh, that wasn't misspelled. enum.type. Does it not have type? Oh, it's tag type, not type. And that goes for packager as well. Oh. I will need to fix that. Get it out of my face. It's scary. The formatting there. Optype.py module. Really? Certainly it doesn't. And these errors might be Protex.op. That doesn't exist. 248. Uh-oh. Wait. Uh-oh. Rip. This needs to be... just like that. Module? Hey, extractor is compiling. 251. Module. I don't know if it's working, but everything's compiling, so that's a win in my book. Now, the moments of truth, where we build a artifact in the tool, call run, have it package an artifact, evaluate what's wrong with packager, likely many things, then debug our logic in extractor. But first I'm gonna go to the bathroom. Okay, let's start by doing this. Let's build everything. If the script is the last thing, we don't need to call hyperscan, right? Because if this is the last thing, we're not anticipating anything else to come out of this. Let me fix that right now. So in the case where we run this, this is only, all this nonsense is only necessary if we're done. So if op index is the last op index, we have our current extraction target, and we have a start of and end of. Start of and end of are just yeah, so we do need to set current extraction target, but if op index is equal to q.length -1, make sure so don't worry about any of this at all. Otherwise, do worry about it. So if this is the first item, build a match for Senpai to run against. If this is the last item, can I do this in the case where, can I do this here as well? Can I say if op index is 0 or opq length -1, that sets current match equal to the entire text? We then need to say no, because we now need to update current match. We need to re-update it. Yeah, so this is, instead of current extraction text.length, this is whatever, wait, it is current extraction text.length. Current extraction text.length just got updated, so it's really, well, it is current extraction text.length. And then I can give the garbage ID. Cool. So pass entire text if this is the first op. We're doing that. This really is last extracted. I flipped on this like 4 times. Meaning it's not a good name. This should be last. Should be latest match. I think this is the best naming that I've had for these two variables. We have latest and we have latest, last, current, previous. I think latest is probably the best. Because current really doesn't reflect. Current and latest are pretty similar in terms of meaning, but latest I feel kind of reflects that, hey, this is just the last thing that we've had. Latest extract target, I like that. Latest, I can get used to this name. Latest extract target, we have a garbage ID, we have a latest match getting assigned. Alright, that's cool. So, yeah, don't do extra work if you don't need to. So, otherwise we need to do work. Otherwise we need to do work, basically. If this isn't the last operation index. And if it is the first one, then we're assigning operation. Where did... Yeah. Do we build? No idea if we build or not. My build panel is over here. Still build. So this gets passed into here, and we don't do any more scanning. After this is done, we're done, which is great. I need to... I need to tell it where to find the Protex lib. Get extractor definitions or else unreachable. What is our webs conf.json looking like? Operation queues, we have extractors, right? This needs to be extractors because I changed that apparently. Pi include path. Am I doing that? Let's build again. Access of a union field integer while field string is active. That's not good. What is that serializing as? That is definitely a 0. Yeah, that is not a... That is not a 0. So my next question is, are these reflective of the order? Because if they are, then great. Alright, so this is kind of hacky. I would like to retain like using that, but it actually makes packagers' life way easier if these are already defined. If I just record indices instead of values, I can show you what the problem is. When using a capture and asking for that, if we look at the DOM elements here, if we look at its value, let me copy JavaScript. If we ask for its value, it's giving us that string. If we ask for its, is it the label? I think it's just inner text. It should be text value. I think it's like display value. Because selectors can have the actual option. Like there's a name and a value. I forget what option actually has for like, let's see here. What is its, because I'm not just writing the value. If I just, let me just go into the Protex, or let me go into render code. If we're looking at, I need to fix render too apparently. Whoever writes pattern select, yeah, so it's the text is what we're after. No, just text. Apparently that's undefined. Let me try. Let me see what happens when I change highlight pattern capture to text. Again. And I want to start using a value. Yeah, that's fine. And for data, over in app source include pattern is a number. This is what I want. Pattern ID. This is like pattern index actually. It's really just pattern index, but implements me. Oh yeah. I'm gonna do that at some point, but not today. Can't I fix this now? Wait, is this backwards? This might be backwards. That is not backwards. This is disgusting, I need to fix this. So let me not touch, let me not touch that right now, but I will fix that because that is bad. This was prior to having a definite way to do this. And there was also another like string approach that I was using, just a list of the values. The thought there was I could use that to also write the change the value too of the actual text that's displayed as the operation type. Where I was modifying scripts. I want pattern select value. Pattern select dot text. So that's cool. But where do I assign pattern select value? So this is no longer value. This is for the patterns container index. Obviously it's a number, Caleb. So pattern index is 0. Your value is now pattern index. Perfect. Where else am I using value? That is it. You are now pattern ID. I should fix this broken formatting. It's over 100 columns. Oh yeah, it's way over 100 columns. Let's do that. You are also way over. Let's do that. Alright, that's looking good. Packager needs to change. Packager needs to get fixed. Look at this nonsense. Why is this on the same line? It's not. Everything is right with the world again. It's a miracle. Okay. Yeah, that's a problem. might be okay. Text does not exist on HTML select element. I might actually just have to use value, and then I might have to set a property of pattern index onto it as well. I'd like this to be more boxular on startup. I did not just use the word boxular. I think I meant square. More of a more square rectangle. A rectangle with square-like sides, but not equal sides. A square that closely resembles a rectangle. I have a solution for this current problem that we're facing. I could actually set a property of... Here's the quick fix. The long-term fix is I make a new TypeScript type for a pattern select. Is a pattern select entry, basically. And that keeps track of the index as well. But I don't want to deal with that nonsense because I'm kind of using them everywhere, pattern selects. So I'm just going to set a property of pattern index. I'm going to set a property pattern index, or set attribute, sorry, of pattern index on each one of these selectors. And, well, just the selector itself, not the option. So I'll set pattern index in the option, and then I get to use, I don't have to change too many things. So, instead of text, value, this is value still. So new option, whoops, can I get the selected option? How do you get selected option? Because isn't value, like, value is giving me the current options value, I think. So I need to ask the get currently selected option. How are we getting currently selected option? Is it not just value? I can use selected index to do this. So, right, that has the selected index property and I can use that. Okay. So, value is still a string of pattern index. I set a new option. I set pattern select. This is just value still. This is also value. This is nothing. This is pattern select dot options at pattern select dot selected index of value. Unless I just set the actual value as the pattern index, which would be wrong. I broke this somehow. I'm pretty sure I am now passing I want to pass text still, I think. But just to verify that this is the issue, well, I can do this, right? On highlight capture, pattern select dot options at pattern select. This is going to, wait, that's fine. Dot selected index dot text rather than value. And at this point, do I so is value just text is what? No, it can't be, because the options themselves are what I'm seeing. Of course there's no selected index. Because wait, we're doing the same thing. This is exactly the same code, right? I didn't need to nuke contents of this if statement. It looks like it was able to call into the extractor. Unfortunately, didn't actually write anything because the config was empty. Let's try running it again. Oh boy. An invalid enum value. Access of union field S while field S is active. Wonderful format string. Why is that format string not working? Oh, that's just the line, right? Tag name. It's angry on line 252. Maybe I can activate it somehow. I guess I could initialize it via init union, right? Is that gonna work? That might work. I could also do you could do this, right? Does it want me to initialize it like this? Because I can, if it wants me to. What do you think about that? Zig compiler. He's happy. The extractor's happy, I think. This is incorrect, right? Because, this is just whatever came out of the Python module. Check this out, right? Can't I do this now? So, work. Cool. I don't think that worked. Try to capture school. What did we just try to do? We just tried to... I just tried to look at... I tried to find, yeah, that's a bug that I will need to fix, because this is not working as expected. Because what happened was Hyperscan compiled qualifications and work as it does. I came in here and asked for qualifications. I passed that to script. Script went and did its thing. It just passed through the text. This then sets the actual text pointer, text slice, to just what you're seeing now. So qualifications through to the open paren. This then decided to... This here then decided to... So my matches should be the last matches, actually. Right? Because I want to maintain matches, but I want to switch matches. I want to switch matches after after calling. Matches need to belong to the extraction target, essentially. So the matches that I'm dealing with here need to correspond with a script, not like global entire text matches. So that is where I think I will leave it, and I will write a to-do to fix that tomorrow. Basically, I need to have a to-do. This is a fix me. These a latest matches pointer of some sort. So this will point to the current matches list. This could point to the latest matches. Figure out which matches to... We need to work with the correct set of matches here. So I guess this logic could implement something similar to how the scripts work, where we have a starting index, and the starting index then carries over to here, and depending on I'm not sure, this could just be a slice of the match items. So like we could actually have just a slice representing the current items that we want to operate on, and that gets assigned first initialized to similar to how we first initialize our latest extraction target. We initialize our matches target, basically. We have latest matches, and that's just a slice of items, basically. So again, after getting our matches, which happens up here, set this to be the initial slice of matches, come down here, and after scanning again, which is where exactly? Right here. After scanning again, we need to set the match list to be the slice of current matches. And I end up not popping anymore because is it okay to add more matches? We add more matches. Is it okay to reset every time? No, it's not, because again, back to this initial issue of I don't want to nuke the global matches that we're gonna retain throughout this entire operation queue procedure. So this will be something that I'll fix tomorrow, and I think I'll just kind of stew on it for the rest of today. But that has been day 34 of Protex work. So thanks for the people who stuck to this point. I will see everyone tomorrow.